Hey everyone, it's Chat here. Today we are tackling the LeetCode problem, climbing stairs. I'll walk you through how it solved this in a coding interview, from understanding the problem and devising a plan, to coding, testing for errors, and evaluating time and space complexity. I'll be solving this problem in Python and I'll think out loud and ask clarifying questions, just like in a real interview scenario. Let's get started. So let's start to understand the problem. Let's start with the problem statement. So we are climbing a staircase and it takes n steps to reach to the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb up to the top? Let's take an example here. So, well, before taking the example that is given here, that is the following. So the only input here is n is equal to 2. Let me restate the problem. So as input, I'm given n, and that's the number of steps to reach the top. And each time we have two options, either climb 1 or 2 steps. And what we want to compute and return is the number of distinct ways to climb up to the top. So if n is equal to 2, we know that, so we can represent this, there are 2 steps, right? First step and the second step. And I do have a few questions here. Where do we start from? Do we start from the first step or from the step 0? So if we look into this example here, we can either make 1 step and 1 step, or 2 steps to reach to the top, right? Okay. So yeah, we are starting from 0, let's say. So if we have this one here and here, we can make either 1 step. Then from here, we know that the best option is to make 1 step. Else from here we can make 2 steps, right? Okay. So the answer here is we have 2 options. One, we can make 1 plus 1. And the second option is making 2. Now let's think about another example. N is equal to 3 to actually figure out what's going on here. It's actually also the example 2 given here. And I just want to point out that n is between 1 and 45 as given in the constraints here. So if n is 3, which means that we will have something like this, we can do 1 step. If we do 1 step, we end up with the same situation. So we end up with, 1 plus this one, right? And this, we already know the response, the answer to this one. That is, we have 2, the number of ways, distinct ways to climb up to the top is 2 from our previous example, right? So this one gives 2 two different options, distinct ways from the first one. Let me make it clear. So if we make 1, then we end up with this array, so we know that we have two options. If we make 2, then we end up with only one step remaining, and there's only one option here. We'll make one step, right? So in total, we end up with 2 plus 3 . So what are we doing here? So this is actually, we can see here a recursion. Because if we are given an, so we already know the answer when we have n is equal to 2 and n is equal to 1 is simple. We know these base steps, and then from n given n, we know that we will have the answer climb stairs of n minus 1. Why would we have n minus 1 if we made one step, right? And if we made 2 steps at the beginning, we will have climb stairs n minus 2. And we make sure n is strictly superior to 2, because if not, we already have the answer, right? So this is my first option, my first solution using recursion. But we will face an issue here because we are computing n minus 1 and n minus 2, and this one would need n minus 3 or n minus 2. This one will need n minus 3 or n minus 4, and we will have a lot of repetitions. So we have multiple options here. We can use we can store actually the answers for. So what we did here was, okay, we started from n and wanted to compute the answer for n given n minus 1 and n minus 2. But I think we can do the other way, from bottom to the top, maybe with an array where we will have, we know that when n is equal to 1, answer is 1. There's only one way, distinct way to climb to the top. When n is equal to 2, we know that it is 2. And now that we know this, we can build this one pretty simply, right? This answer will be this one plus this one, okay, n minus 1 plus n minus 2. And then for this one, we would know so how can I achieve this? So I can have actually current that will start with 3, and we can current index maybe. Current can be 3, and then current value can be previous plus previous 2. First and second. We can call them first and second. Then when I'm computing for current is equal to 4, the thing is first becomes second, second becomes, oh, maybe I can have just previous, right? I could have previous, yeah. No, it's better to have first and second. And second will become current value, right? Yes. I have maybe a better solution with this one, but let me just follow this. And so what happens is that once I do this, first becomes second, second becomes first, sorry, and current value becomes second, and the new current value is actually the sum of those. So first plus second, and the thing is when current, so we do this while current strictly inferior to n. If it is equal to n, we can return current value, right? Let me, so what's my idea here? So what I'm doing here is I'm starting from, so first of all, yeah, now that I've devised a plan, let me carry out the solution in Python, code it in Python then. So as I said, if n is equal to 1, or n is equal to, if n is strictly inferior to 3, right, we just return n. We know that n is superior or equal to 1, so it's either 1 or 2, right? Either 1 or 2. We just return n, because for 2 it's 2, and for 1 it's 1, sorry. Here what I do is I'm storing first and second, the two variables that store actually the n minus 1 and n minus 2. Maybe I can better call them. So previous and the one before, maybe I can call them previous 1 and previous 2. Yeah. This way it's previous minus 1 and previous minus 2. Previous one is n minus 1, I mean current minus 1 and current minus 2, right? Value of current 1 and value of current minus 2, right? And I do have current that starts at 3, and I do have these where we know that we start with 2 for previous 1 and 1 for the other one, right? And while current is strictly inferior is inferior or equal to strictly inferior to n, so current is 3 and current val is prev1 val prev2 val, right? As I explained earlier. And now that I do have this, while current is strictly inferior to n, what do we do? First of all, prev1 val becomes prev2 val. Then prev2 val becomes current value. What I did here is that I ignored the last one that we do no more need, and I'm just using current and current minus 1 as new values to compute current value. And what I do here is returning current value. Let me just, test this with 2 different cases, 3 and 4. For n is equal to 3, what happens here is that n is not strictly inferior to 3, so we end up here. Previous 1 value is 2, previous 2 value, that means, n minus 1 is 2, and n minus 2 is 1. 2 plus 1 is 3, so current value is 3, and then we do previous 1 val. We just ignore the value of previous 1 val, and we get the value of previous 2 val in there, and current value becomes the previous one, and the new current value is the sum of both of them, and we return this. This works for n is equal to 3. That gives us 3 simply. For n is equal to 4, let me just check that it works correctly. So what happens here? So I can make either one step. If I make one step, then I end up with an array of 3, and there are climb stairs of 3, that is 3 as the number of distinct ways to climb to the top. And if I make 2 steps, and then I end up with these 2, which gives me climb stairs of 2, which is 2. So 2 plus 3 is 5, and the current value should be 5. And we can test it here. So we have n, and we can add the test case for maybe for 5 if it works. Did I miss something here? The time limit exceeded. So there's a clear problem here. Oh, I'm not updating current. And current gets incremented in the loop until reaching. So right, there's an issue here for climbing stairs. Let me simplify this a bit, because I can simply have so let me compute this for full test case for full if Am I getting always? No, there's a clear problem here. I'm always giving some value that is lower than expected. So let me just show the results. So for previous value, so I could simply have current and current and current value, right? I can call them this way because it's a bit clearer in Python. So current is gonna be 3, and current value is gonna be 2 plus 1, 3. So it should be, current value should not be initialized immediately. Okay, current can be equal to 2, and current value can be equal to 2. That's right. And while current is strictly inferior to n, so n is strictly inferior to n, what we are doing here is current value the previous value is going to be 1. So the current value is going to be so first of all, I need a temporary variable that's going to store my current variable. That is 2. And then my current variable is going to take current variable plus the previous variable. And then previous variable becomes this temp. So this should be okay. I've just recoded exactly what I had previously. To simplify naming, and it now also works. So yeah, let me just, so yeah, this is the solution to this problem, because I did not need that first and second, as I said here, where I'm just, current value is the one that we are computing, and previous value, this is current value, and this is previous value. And when I want to compute the new current value, what I do is I just store this in temp, and then I compute new current value from this and this. And then what I do is simply put back that current value into previous value. Let's now submit the code to see if it's working. Yeah, that's it. Now, if we think about the time and space complexity for this problem, we are just making some operations here from n equal to 2 to the given n. So it is O of n in terms of time complexity, and in terms of space complexity, as we're not storing anything else other than variables, simple variables, it is O of 1. Yep. There we go. That's it.